Good morning. Thank you for coming. I've prepared 4 topics to talk about. What I figure is I'll do the first 3. We'll see how much time we've got left, and then we can decide whether we're going to do the 4th one or go straight to the questions, because questions is always the best bit. So, can we get the PDF? Great. Okay, so put your hand up if you were in Warsaw at TYPO last year for the OpenType 1.8 announcement. Got a lot of you. Put your hand up if you watched the video of it. Yeah. Keep your hand up if you watched the video more than once. Yeah. More times than you've seen Star Wars? Okay, right. So it was really exciting, and a big thing was made of it. This is what the announcement of OpenType 1.3 looked like in September of 2000. Specifically, this is the part of the announcement that dealt with the removal of multiple master from OpenType. So when OpenType was first announced, 96, 97, the collaboration between Microsoft and Adobe, Adobe's multiple master format for interpolated fonts was part of OpenType. Now, in the first 3 years of OpenType, a lot of groundwork was being done, but not a lot of fonts were being made, not a lot of fonts were being sold. There wasn't a lot of support in the system yet. It took quite a long time, certainly a lot longer than variation fonts is taking to find its way into operating systems, into APIs and stuff like this. And so there was this 3-year period where ostensibly multiple master existed in OpenType, and then it was taken out really before OpenType began to take off. So we've had 16 years without interpolation in the font format. Now, you could still make GX fonts if you were so inclined, and certainly interpolation has been very important during font production. I'm sure most of the type designers in the room use interpolation in various ways within their font tools in developing their fonts, even though what they're producing is single standalone fonts without interpolation in the format. Even so, the fact you don't have interpolation in the format has an impact on the kind of fonts that you make and also the kind of fonts that get commissioned by people. And certainly in the work we've done in the last 16 years, if interpolation had been in the format during that time, we would have approached most of our projects in very different ways, and we would have encouraged our clients to think about their projects in different ways. And the fact that that hasn't been an option has meant that most of what we made not only doesn't interpolate, but couldn't interpolate. There's a lot of work that's going to need to be done on some of our projects when people come to us and say, in the coming years, and say, oh, can you make a variations font version of that thing that you made for us 20 years ago? And I'll say, well, if 20 years ago that was in our heads as being a future possibility, we would have done things very, very differently. So interpolation is back, and so I'm going to be talking about some ideas I've had about things we could do with interpolation now that we've got it back, beyond what's already been talked about in terms of variation fonts and what I think of as font-level variation. So if you look at OpenType variations technology, you've got stuff that happens to glyphs within design space, but the design space is really defined at the font level. So we have this fvar table, and the fvar table contains the axes, and our way into doing things to glyphs is via the fvar table, is via these axes. And so really everything we're talking about is what I consider font-level interpolation, because it's stuff that we approach at the font level. Now, it's perfectly possible to make an axis that only affects a single glyph, of course. And so we could have hundreds and hundreds of axes, up to 64,000 of them, each affecting only an individual glyph. One could make a font that way. What I want to talk about is something slightly different from that, which is thinking about glyphs themselves as having a design space, and the things that we can do with those. I've got some use cases of problems that exist in layout that could be solved using this approach. And really what I want to do is encourage other people to also think about these kind of questions. What other aspects of layout, what other aspects of typography might be addressed by what I'm thinking of as glyph-level interpolation. I also want to make a point about the word interpolation. I'm using it in a very broad sense that we tend to think of interpolation simply as something that happens between two things. We already know in the variations format that, in fact, we're talking about a thing and deltas from that thing, an interpolation within this space. And we're still thinking in terms of axes. There are other ways within the format we could also think of addressing things in a more programmatic way that really may be involving axes, but it doesn't make sense to think in terms of interpolation in axes, but instead of having things within the axes moving to things external to the axes. And I'll get into this in more detail because that's where I think variation fonts get really interesting, thinking about the ways in which you can get at the interpolation data and use it outside of things like user interfaces. So, interpolable components. This is something that occurred to me actually during one of the first of the OpenType variations meetings that I attended. And I know independently it had occurred to Tom Rickner and Dave Opstad. And it's probably occurred to some of you as well, that once you start looking at the technology, you think, oh, well, hang on a moment, here's an interesting thing. So here we have some consonant conjuncts from the Noto-Tibetan font designed by Toshi. And you notice in this we have these these forms that are based on a particular letter, and they are clearly, obviously, all the same letter, but they're of different proportions, they're slightly different widths, they're different shapes. Some of them have a really long tail, some of them have a short tail. This is actually all built, in the source at least, using composites. So all of these things are defined, and those of you who use glyphs, perhaps you've used these yourself, what Yoko's smart components. And this is a kind of ingredient glyph that has its own design space. And in this, Toshi has defined a certain number of axes and a bunch of outlines. And this can be manipulated and then used as a component in other glyphs. And so all of these that I've highlighted in orange are in fact composites based on this ingredient glyph. So one of the first thoughts you think is, okay, well, maybe that's something we should incorporate not just in the source end, but also in the font format, because at the moment, when Toshi generates the font, everywhere he's used this component gets decomposed into a flat glyph. And maybe we should be able to capture this sort of behavior in the font format itself and preserve this going through. Obviously, there's really interesting questions about, how do you hint something like this, and also have the hints applied when you're performing these manipulations in a composite. Looking at to what degree is this actually kind of save us anything? I mean, the great use of composites is that you can carry hinting across from one glyph to another. You can put multiple glyphs together into a composite glyph, and you can save a lot of space. So one of the interesting questions is, if we do this in the format, what does it actually gain us? And that's something that needs to be investigated. Another aspect of this that gets really interesting is this. So this is the first version of a Noto-Tibetan, and it just had 2 weights. But obviously, this interpolation space within this glyph also needs to exist within the larger interpolation design space of the variable font. And so here, obviously, everything that Toshi's done in the regular weight, he also needs to do in the bold weight, and they need to be interpolable in the same way that the 2 weights are. If we get this into the font format, the math gets really interesting. You've got to think about it, because this is a glyph with a design space within a larger design space. And so how do we specify that? One model is that, and the one I've kind of been thinking in, and where the math was kind of confounding me, was that you've got one design space nested inside another design space. And so all the math that you're applying in this design space is having an impact on the math that you've applied in this design space. Peter Constable suggested another model to me the other day, which is really that the Glyph design space intersects the larger design space. And that, I think, has some very interesting possibilities and also possibly makes the whole thing a lot more feasible. But thankfully, the math is somebody else's department. I failed Algebra 11, had to do it a second time, so clearly I'm not the person to do the math. Once you start thinking about making composites of things that are not simply static components, but components with their own design space, once you start thinking about things being made up of other things that are similar but change their shape, they need to be rotated slightly, they need to be longer, they need to be shorter, you start to see the possibilities for using them sort of everywhere. And you start kind of looking at things like CJK fonts, and you're thinking, there's a lot of things in here that kind of could be made up of things that just need to be a little bit wider here, a little bit narrower here. You get the same sort of thing looking at Hangul. You start to have crazy ideas that maybe we can make like this huge CJK font from just like a very small set of ingredient glyphs with their own design spaces, the font could actually be tiny, and all we'd have is these manipulations, these deltas to move them to where we want them to be. And then you think, well, it's just manipulating objects in space, so we could parameterize the heck out of this. Possibly. Again, the question then becomes, what do we gain from doing this? Are there significant size benefits? Are there processing benefits? Are there, in fact, processing deficits from doing it this way? These are the things to be explored with this sort of approach. Instead, I've decided to look at a fairly simple thing. So those of us who make Latin fonts, one of the things we use composites for very regularly is to make precomposed diacritic glyphs. And one of the things we do is we adjust the size of the diacritic marks for whether they are above a lowercase, above an uppercase, and maybe we adjust them also, have separate ones for the small caps. And the usual way to do this, and the way I did this in the Brill font, is that I've got 3 circumflex accents. I've got 3 versions of all my above accents, and I use a different one depending when I'm making my pre-built things. Well, clearly, these are things that could be smart components in the Glyphs terminology, and possibly smart, interpolable components within the format itself. So rather than my having to have 3 circumflexes, I could have a circumflex object that has its own design space, and I could, adjust it to the appropriate scale. And then that gets sort of interesting, because when you've got multiple marks, you could do some interesting things. So there was a discussion on Twitter a little while ago in the context of actually Cyrillic, certain Cyrillic characters that can take combining marks in certain languages. And you can have stacks of multiple combining marks, and these don't exist in Unicode as precomposed diacritics, and so you need to have some kind of mechanism for displaying them in a font. And Lucas pointed out that he prefers to replace accent on accent, the actual kind of just sort of stacking of components, with a double accent glyph, which is lower in total height, which makes perfect sense from a design perspective. It's a nice refinement, but a double accent glyph is essentially, it's a ligature of 2 combining marks, which then operate as a combining mark. And that's great if you know the languages that you're targeting, and you know exactly what combinations of marks exist in those languages, such as the combination here, which occurs in Vietnamese. And we know what combinations of diacritics and tone marks occur in Vietnamese phonology, and so it's very easy to design these combinations of marks in this way. But I want to be able to do things like this. Or rather, I don't want to be able to do things like this. I have customers who are dealing, they're publishers, they're scholarly publishers, they're dealing with stuff coming in that contains arbitrary combinations of combining marks on bases. And obviously, no real text gets this crazy, but I need a mechanism that can do this crazy to ensure that my customers can handle anything that their authors and their editors bring to them. But if we've created the marks with their own design spaces that include, a height axis within the glyph, it seems to me that we can take advantage of things like OpenType GPOS mark-to-mark positioning and still get the kind of refinements that Luke wants in the design of these things, because shouldn't we be able to perform that manipulation of height programmatically based on, for example, the Y offset in the GPOS table for the mark? So the higher the mark gets relative to its default position, the more the axis says, make this shorter. And so we could conceivably have multiple marks being applied and be adjusting the height of them, and at the same time as adjusting the height of them, adjusting the actual position of the anchor mark position, and so that we can perform this kind of graphic refinement in the height of the things dynamically based on where the marks are falling. So that seems to me something that's probably pretty doable. It's it's just math, really. So shouldn't be a problem. Obviously, you got to once that exists, you got to your design approach needs to take into account this capability if you're going to make use of it, and you've got to think about marks in this new way. But thinking about things in a new way is kind of why we're all here this morning. So that was the first thought, the idea of making use of interpolation within composites. Now, when I got to this stage in preparing the slides and the presentation, I thought, well, it's not just composites. We shouldn't think of glyphs with design spaces only as things to use in composites. Really, there's no reason why we shouldn't think of any glyph in a variable font as having its own design space that we can address programmatically within the larger framework of the font axes. So that's the kind of thought to bear in mind through everything else I'm going to talk about this morning, because everything relies on this idea of glyphs with their own design space and then coming up with ways to address that design space. So I'm going to talk about matra interpolation. This in orange, this is the ICA, it's the short I vowel sign in the Devanagari script. And it has this a number of interesting characteristics, one of which is, Devanagari is a left to right script. Phonetically, the vowel follows the consonants, but it's actually written to the left of them. So that's why it's on the left. And then it's got this arch. And in handwriting and in manuscripts, the tendency is for the arch to reach over to generally the point, well, you can sort of see it here, the point above the final vertical of either the consonant letter or a sequence of consonants forming a conjunct. And because the sequences of conjuncts can be wider or shorter depending on how many elements they have to them, the length of the ikar can be very narrow, as on letter Ra, or it can be very wide. So hot metal fonts didn't do this. They had a limited number of these variants. Phototype, same sort of thing. Early digital fonts, again, kind of followed those models. When we came to do the Adobe Devanagari font, I'm not even sure what year that was. Thomas, you might remember. Early 2000s, I think. Yeah, mid-2000s. It suddenly struck me, well, hang on a moment, we could do this in OpenType, because all we'd need is a sufficient number of widths of these things, and we can just have contextual substitutions in the G-sub table that says, oh, you've got a conjunct ligature that's this wide, use this particular ikar glyph. And the only kind of fiddly bit of preparing it was figuring out how many of them we need and what their widths should be. And I did some measurements on the conjuncts and on the letters, and I worked, I think it was a +10 and a -25 tolerance of an ideal position, and then figured out how many of these we needed in order to be able to kind of cover everything in a way that looked nice. And then I asked Tim Holloway to design a narrow one and a wide one, in addition to the default one. And then we just interpolated. I did my interpolations in my sources, and then I made a whole bunch of these things. I know Georg has, he's got a way of automating this in Glyphs. And so I've seen a lot more fonts doing this since we did the Adobe version. There are places where it kind of falls apart a bit, and this is one of them. So this is a conjunct that is made up of a sequence of 2 half forms and a base form instead of being built as a ligature. And what happens if you type this in the Adobe Devanagari is you get the default ikar, not an appropriately wide one. And the reason for this is, in order to get the appropriate wide one, in the contexts in the G subtable, I would have to probably classify all of the half forms by width into some groups, and then I would have to specify every possible way of getting to a particular width in terms of particular combinations of half forms and final forms. It's doable. It's not kind of really feasible. We kind of instead took the approach that we were going to build ligatures for all of the conjuncts that we knew were going to occur in a particular language that we were targeting. But ideally, we'd like to be able to solve this problem as well. Now, as I said, in the process of actually kind of creating these variants, I used interpolation on my source end. But what actually went into the font was 20-something variants, and all the G-sub to do them. But if we can have an ICAR design space for this glyph in which we could contain the narrow and the default, probably expressed as well other variations as the default as being the thing, and the narrow as a delta and the wide as a delta. If we could kind of get that in the font, all we'd need is a way of telling that glyph what part of its own variation space to use in a particular context on the page. Now, a little bit of an aside, we don't do the really long ones anymore. So shortly after we did the Adobe Devanagari, the Vodafone Hindi for Dalton Marg, Fiona came to the conclusion that actually the really long ones are quite distracting in text. They look all right in handwriting, but in typographic text, it does weird things on the page. In order to retain the nice curvature of the ikar, it has to get quite high, it has to get quite heavy. And otherwise you kind of squish it and it just looks really ugly. So Fiona decided that moving forward, we were actually going to limit the width. And now we make our fonts with a relatively small number of ICAR variants, and they max out at a certain width, and after that, they don't get any wider. The other side is this is not limited to Devanagari. So we do similar things in our Bengali fonts, and there we're dealing with kind of a smallish number. We find for the Murti Bangla, I actually only needed 4 widths, but then each one has a secondary variant for dealing with these letters that have swashes above them. So it's not just a Devanagari problem, and one of the things I want to stress this morning is that I'm using these as case studies for problems that I think need to be generalized. We need to understand in a generalized way what the issues are and how we should address them in the technology, rather than saying, oh, we need an axis for the Devanagari ICAR. That's not the answer. What we need is a generalized model that solves this problem and others. So the obvious idea is a target anchor, something that we can put on the ligature, on the conjunct, that says, this is the target, this is where we want to reach for. with the ICAR design space. And I've used the term anchor, which is familiar to you from OpenType GPOS, because I suspect what we need is a specific kind of anchor in GPOS. GPOS already defines the XY coordinate space very nicely. So having an anchor, and whether it's an anchor with a specific name that it could be something as simple as that, makes sense to me. And it solves the first case, which is having a ligature being able to say stretch over here. The same thing will work across half forms. Obviously, this is going to need shaping engine support. The index shaping engines are going to need to know how to process this. And in this case, what you're saying is keep that ICAR reaching over any half forms until it hits the anchor on a base form. And so that is very flexible in that model. And also works with our new approach that we're using, where we actually have a limited width, because the design space for the ICAR is going to have a maximum on its axis, and it's not going to go beyond that. We don't do extrapolation in OpenType variations. And so we're just going to say, stretch this to get it as close as you can to the target anchor, and that's going to solve that problem too. The other reason why I think this probably needs to be a GPOS anchor is that it's going to need to be contextual in some situations. And so, again, leveraging what already exists in the GPOS table. So we have a situation here where we've added this Candra Bindu sign, and we actually want to shorten the ICAR because of the presence of that Candra Bindu sign. So what we want to define a second anchor that is contextual, that says, use this anchor if there's no Candra Bindu, use this anchor if there is a Candra Bindu. And that should all be programmatically happening. Now, at this point, I began to think, all right, so we want to generalize this. We don't want to do what happened in the early days of OpenType. In the early days of OpenType, some people at Microsoft, and very bright people, were given the job of implementing shaping for index scripts in OpenType. And basically what they did was they ignored all of the OpenType layout features that had already been defined for other scripts, and they came up with a set of OpenType layout features specifically for index scripts, some of which really look redundant because they could have used things that already existed. I think we want to generalize. We don't want to come up with a bunch of solutions specifically for Devanagari or specifically for index scripts. So what is the generalized thing here? The generalized thing is we've got things moving laterally to specific widths, and we want to handle that programmatically by some piece of information that serves as a target for how far those reach. It seems to me somebody should be able to make a fancy Latin display font with long swashes and be able to say, this swash goes this far, but then if it meets this other letter, it doesn't go any further. That's something we should be able to do programmatically with a Glyph level design space. And so, I think whatever method we come up with is something that should be applicable to any script, to any style of typeface design. It should be up to the font developer to decide how to use the technology. And we just need to make sure we define it in a robust enough way that the shaping engines and the layout engines understand what is in the font format and can apply it. The third case study. This is the complicated one. And it's a complicated one because although what I'm going to talk about is an incredibly simple solution to a problem that's been around for a long time, the problem exists within the context of a much larger problem. So Kashida is originally a Persian word that means elongation. And in Arabic script, it refers to this ability to elongate certain strokes that connect letters, or to elongate the letter itself, the two different ways of thinking about the same thing, in order to make a word wider. And since fairly early on in the typesetting of Arabic in Europe, this has been understood as, we can justify text this way. All you need to do is stick one of these things in and just push stuff apart and you can justify text. And this is exactly what happens still in Arabic justification algorithms in Word and InDesign and other places. So this is some classical Arabic poetry, which is rhyming couplets, but with a kind of verse, a metrical verse division in the middle. And the traditional way of writing them is obviously from right to left, and you write the first half of the verse, then you have a gap, you write the second half of the verse, and so on in these couplets going down. So what we've got is two justified columns. Now, if you look at modern publishing of Arabic poetry, one of two things tends to happen. Either they don't bother justifying the columns, or they apply the justification algorithm in whatever software they're using, and they'll get something that looks like what you've got on the left here. So you can see, these Kashida elongations are being inserted in various places to kind of force justify these lines of text. On the right, you've got the same text in a book that was typeset for Brill by Lara Captain, and it's beautiful and it's elegant, in part because Lara is beautiful and elegant, but she's also using a software that allows her to be beautiful and elegant when she's typesetting Arabic, which is the Tasmim plugin for InDesign from Decotype, and using Decotype's fonts. It's very useful to compare these two settings. One of the things you notice is that there's relatively few Kashidas in Lara's setting of it. She's used a lot of different methods to justify the line length. She's using wider forms of some letters. She's using variants of some letters that are wider than others. She's adjusting the interline spacing. She's moving things relative to each other in interesting ways that allow her to perform this justification in a kind of balanced way. And you notice she's also cheating. This line gets slightly longer than the others. She's doing exactly what a scribe would do in that situation. The scribe will cheat because he knows, or she knows, that she's got a certain amount of stuff to get onto that line. All her other lines are balanced. She doesn't want to make everything a little bit wider to satisfy the need of that one line. Cheating is difficult to do programmatically. Other things are easy to do programmatically, relatively speaking. So keep these two models in your mind. A slight diversion now before I start to talk about interpolation and Kashidas. This is some specimens of the Ruqa script, a particular style of Arabic that does not use Kashida for justification. Kashida is unknown in this style of the Arabic script. Instead, the style of the Arabic script has its own methods of making things shorter and longer. So in the middle here, we have the same word typeset in, looks like kind of 16, 20 different ways, just with different forms of some letters, different arrangements of the letters to each other, different ways of spacing it. And so it allows the letter to get very narrow or substantially wider. And then on this side, we have an image that I want you to keep in mind in the panel session at the end of today, where we're talking about non-rectilinear spacing. Because like many other things, it's something that Tom Mehler's been doing for 25 years. So this is, again, the same phrase, narrow and wider, in some cases being dealt with by variant letter forms, but mostly through spacing. He's adjusting the vertical relationships of the letters to each other so that in some cases they nest, in some cases they don't nest. And the spacing just kind of works because he's not tied to the rectangles that we are, for the most part, tied to in OpenType. But the other thing to take away from this is, okay, we've got a style of Ruqa, a style of Arabic called Ruqa, that doesn't use Kashidas, which means that existing justification algorithms for the Arabic script in all that software out there is unusable for this. And if you were to apply it, it would be a mess, and it wouldn't be appropriate to the style of the script. And this is a very important point. In Arabic, the methods of justification used are dependent upon the style of the script. And what that should tell you is that you cannot do justification entirely outside of a font. You cannot do justification at the character level, which is what all Arabic justification algorithms try to do. They look at strings of Unicode characters and they say, here's a place we can stick a Kashida, and here's another space we can stick a Kashida. And maybe that's true for some styles of Arabic, is not going to be true for others. Now, Eliezer Cohen, the primary inventor of OpenType, he knew this. And that is why in OpenType, there is a table called Justification table, the JSTF table. To my knowledge, it's not implemented anywhere. So it's been in the OpenType spec for 20 years, and no one's implemented it. I've heard some people grumble that it's unimplementable, maybe so, but the idea that it solves, which is this one, that being able to provide information at the font level to help a justification algorithm, that's an idea that it's a problem that's still here. If not the justification table, what? Because we still haven't solved this problem. Moving on. So this is how justification algorithms tend to work. You've got a piece of Arabic text, and you want to make it longer. You want to fill a measure with it. Justification is filling a measure. So first of all, you calculate how much space you need to fill. Easy enough. Then you identify the places that you think it's legitimate to put a Kashida. And again, this is some algorithm, and it's happening at the character level, not at the font level. It doesn't know anything about ligatures in your font, for example. It might break. You might have preferred ligatures in your font that you really want to happen all the time. This is going to stick something in the middle of it and break the ligature. It makes using contextual alternates to form ligatures hair-raising in Arabic fonts, because you might get a Kashida stuck between two contextual alternates that no longer connect, and they don't connect with the Kashida either. And the other thing is, this is one algorithm. This particular algorithm, which is Adobe's, has decided these are the places to put the Kashida. Microsoft's algorithm will give you different positions, and I'm sure there are multiple ones out there. So one of the thoughts I've had is that, like variation fonts, like recent work in OpenType spec, this is something that should be standardized. Font developers shouldn't have to and users shouldn't have to deal with, multiple inconsistent ways of justifying text. We should be able to produce some predictable results. So once you've done that, you stick in this thing. This is the Arabic tatwil character. Tatwil is a very silly word, whose primary function, I think, is to be able to distinguish between this approach and a true Kashida. A tatwil is a kind of extension glyph. And what you do is you stick in as many of them as you need to fill that measure. And typically you will, an algorithm will spread it out equally between the words. And you put in as many of them as you need, and it's okay, you can allow them to overlap slightly. So you put in like one more than you need, and then you squish them together. And hey, presto, we've got justified Arabic text, problem solved, and you go on for another 25 years without really solving the problem. Because what we want to be able to do is this. We want to have Kashidas that curve. We want to have Kashidas that remain within the style of the script, within the style of the typeface. This model, it requires you to have a flat baseline adjustment, a flat baseline connection. It's the only way it works. You cannot do any kind of curved Kashida within that model. The reason you can't do any, you might be thinking, well, couldn't we do a ligature between all of those, individual tatwils and some nice elongated thing? The problem is, all of your OpenType layout, so your basic Arabic shaping stuff, your positional forms, any contextual stuff you've done, any discretionary stuff you've done, all of that has happened before line breaking happens. And so it's been run, and then you need to justify the text. And it doesn't run again. So you can't make Kashida ligatures, you can't do stuff like that after you've done the line breaking. You can only do it at this one time that OpenType layout runs. We've spent 2 years in the OpenType working group coming back to this question again and again of how can we do at least some OpenType a second time, do it after the line breaking. So do all the basic shaping, do the line breaking, do justification, and then do refinement via OpenType without causing reflow that changes the line breaks that you've already established, and then recursively doing it again and again and again. We don't have an answer yet, but this is what we should be able to do. And again, my solution to the small problem within the larger problem is that we have an interpolable design space for the Kushida where we have narrow and wide forms, and we have multiple forms to connect with different shapes on either side. And at the justification stage, the justification algorithm should be able to say, right, we're going to put in this Kushida, and it needs to be this wide, or it needs to be this wide, or it needs to be this wide. And if we can solve that for this, then we can start to think about solving it for this as well. Then we can start to think about applying Kushida in the cascading styles of Arabic, like Diwani, like Nastaliq, which is the preferred script for a major language. But at the moment, it's either completely broken by justification algorithms, or you need to do things in the font to prevent the justification algorithms from trying to insert Kushidas in the first place. You'll notice that in this version, in the previous ones, I had all the vocalization marks from the poetry. In this sample, I've left them all out because once we've solved this problem, we're still left with the problem that the interaction between mark positioning and spacing remains the weakest link in the entire OpenType model. And there is still no easy way to contextually adjust the position of things relative to what's happening in the spacing. But that's something I've talked at length about in previous conferences. So that's the Kushida problem. And it seems obvious that if we have Glyph design spaces within the larger framework of variation fonts, this is another place where we could usefully apply that. But we need to solve a lot of other problems around that in order to do so. So we are at the 1050 mark. So this is where I pause and say, do you want to hear about math variant interpolations, or do you want to start asking questions? Anyone? Math? All right. Okay. It won't take very long. So when OpenType 1.8 was announced, if you look at the version of the spec, and particularly if you look at the diff version, the one that shows the differences between the previous version and 1.8, you realize that variation technology touches almost every aspect of the OpenType spec. Almost every table contains some, even if it's just a one-line comment saying, don't use this bit in a variation font. Almost everything's been touched. The two notable exceptions are the SVG table and the math table. And during the course of the meetings, it was, particularly on the math table, it was just decided we're just, deliberately going to ignore the math table for 1.8. And then in future, we can begin to think about how variations might apply to that. So I've begun to think about how variations might apply to it. And the common, the registered axes in OpenType variations, the weight and width, size, for example, don't really apply to math if you're making a math font. Or if they apply in a different way than they do elsewhere. Because in mathematical typesetting, weight has semantic value. So a bold letter has a different meaning in a particular mathematical context than the regular does. And italic has a different meaning. And this is why Unicode actually, even though for most general typesetting will say, italic is just styling of characters. You use the same characters whether it's Roman or italic. When you get to math, there's a whole set of math alphanumeric characters in one of the upper ranges of Unicode that can be used in the context of equations to capture these semantic meanings. So it doesn't make sense to have a weight axis in a math font. Because, or rather, if you were to have a weight axis in a math font, all of these other weights would have to be relative on that axis. So, if you made your regular bolder your math alphanumeric would have to get bolder still. So it just doesn't make a lot of sense. Now, possibly the size axis could apply, but if you've ever looked at math textbooks and math typesetting, basically equations are all kind of in the 10 to 12 point range. Nobody does 36-point equations. We don't need display size variants for math typesetting. So if we're not going to use font axes for those sort of typical things that we're doing in fonts, what might we use axes for? What kind of interpolation space might be useful? So here's an equation, and you notice it's got these alignments in it. So in the middle, there's this central line to which everything else is aligned, and this is very common. And this is one of the math constants that we define in the math table. We say this is the height at which things align. So where you have just the single line of stuff, that is that line, it runs through basically the middle of the x height optically, and everything else gets aligned to that, and then things need to grow. So the braces here, they need to grow relative to the height of what's coming down below here, and obviously symmetrically to be above, they're aligned on the central line. The square brackets, same sorts of things happening. This symbol itself is aligning to a particular height. So stuff needs to grow, and it needs to grow and look nice. So what we have in the font is a bunch of height variants. And the math handler, which is like the layout engine specifically dedicated to math that knows how to work with the math table and lay out the equations, what it's doing is it's saying, I need to fill this height with a brace. So I'm going to look for the brace that is closest to that height, and then I'm going to scale it up or scale it down a little bit to fit that height. And in the math table, we put in the information that helps the math handler make the decisions about at what point it needs to go to the next size and so forth. So obviously, you look at this thing, a thing's got to grow, it's got to be resized. Beyond a certain height, so beyond a certain height, things stop growing, and they start being put together by pieces. So rather than us having just endless height variations, at a certain point, we stop doing the variations, and we start building these shapes out of bits that clip together. And like the flat tapped wheel in the Arabic Justification, these are allowed to overlap to be able to squish to the appropriate size, and therefore they need to be straight. And so we lose the nice curvature, and instead we get these kind of fairly static looking braces. Okay, so I don't actually have an illustration, but you can imagine where my mind is going because you've seen what I've already suggested for the other use cases, right? We have an interpolable design space. We have some gigantic brace, and we have some small brace, and instead of having multiple variants, we let the math handler interpolate the height. And I reckon it should even be possible in that design space to make these built versions be more curvaceous, rather than us having to make them straight just so that we can overlap them. We should be able to, in the design space of the pieces, adjust them so that they flow together nicely. And so we can solve this problem, make the math look more refined, have the weight of the braces rather than going up in steps, being nice and smooth. So you've got different braces in different sizes, and there's a nice visual relationship between them. So that's one thought, something we can do with this idea of glyph design spaces. The other thing we do is math fonts already contain the idea of optical size. So in the math font, we have our regular letter K, and we have a version of the letter K that is going to be scaled down for use in subscripts or superscripts, and then another version of the letter K with the optically smallest yet size, which is going to be scaled down for superscripts relative to other superscripts. And so at the moment, what we're doing is for some portion of the math alphanumeric characters, we are designing these optical size masters, and we're putting them in the font as separate glyphs, and they get access via an OpenType layout feature that the math handler knows how to use. And then the math handler is responsible for the actual sizing of them and the actual positioning of them. So the obvious thing is, okay, well, we could, instead of having our multiple glyphs, we could have a single K that has these optical size adjustments within its glyph design space. And the math handler could know that, how to adjust that design space when it needs things of a particular size. And so not only would we have smaller glyph sets, just storing deltas rather than all these extra glyphs, but we could also have more refinement in the scaling of them in particular situations within math layout. So those are my 4 use cases. Thank you very much, obviously, to Monotype and to the conference organizers, and to various people who knowingly or unknowingly helped me generate some of the ideas that went into this. Thank you.